Hi everyone, my name is McLoughlin and my partner for this project is Schiffer. And today we'll be discussing the optimization of a low-budget portable gynecological examination table. As a little bit of background, Project Mesa, which Cameron and I are both active design team members of, is an MHEAL team at Michigan that works to produce a low-budget portable gynecological exam table to service rural villages in Nicaragua. The need for this product originated from the observation that cervical cancer death rates are very high in Nicaragua, despite cervical cancer being highly treatable if discovered early. A large priority of the team is to ensure that the table that we're providing is easily able to be set up and torn down so that the clinician can operate quickly. The optimization of this process is the goal of our project. We used our design table as the main material. As discussed earlier, the tasks we analyzed are the assembly and disassembly processes of the table in order to optimize it. The work environment consists of numerous sites. The testing and analysis took place in the Wilson Center and Lurie Biomedical Engineering Building, which is where our project team works. When the table is fully implemented with the Nicaraguan clinicians, the work environment is the Nicaraguan villages that the clinicians actually operate in. Lastly, the workers involved in this project are the individuals who manufacture the table and are on the project team, as well as the clinicians who use and handle the table in Nicaragua once it's implemented.
The goals and objective of our project are to optimize the time for setup and breakdown of the table, minimize work, stress, and fatigue, and develop a specific list of assembly and disassembly steps. The methods and analysis tools used are MODAPs, a time study, and then a CAD software called SolidWorks. The process and methods. The first thing we had to decide was who would be the subject of study, and that was me, Cameron Schiffer. And one thing to note is that I had a pre-existing experience with the table, so times may be skewed when compared to someone with no knowledge. MODAPs was used to break down the steps to put up the table into time-based calculations. The time study is used as a comparison to the MODAPs in order to measure efficiency of how we're putting the table together and taking it apart. SolidWorks is then used as a 3D visual for what the table looks like and how it's used.
To begin the testing process, a MODAPs analysis was conducted on the process of opening the table. Our team broke the process into 13 unique steps, which can be seen on the left. After providing the unique MODAPs assignments, we see that there are 282 mods for an estimated time of 36.3 seconds. The unique part of the table that the MODAPs steps reference can be seen on the figure to the right, which include the pin leg locking mechanism, the telescoping stirrups, the legs, and the backrest. A MODAPs analysis was then conducted on the process of closing the table. Similarly, our team broke the process into 11 unique steps. After providing the unique MODAPs assignments, we see that there's 276 mods for an estimated time of 35.6 seconds. Also, the table folded can be seen on the right. Following the MODAPs analysis, a time study was conducted from a video recording to validate the assumed method and estimated time. 3 trials were conducted for each step in order to get more precise data on exactly how long each step takes. For opening the table, it can be seen that the average standard time was 68.86 seconds. It should be noted that the steps for the time study were more generalized to avoid timing inconsistencies with very short time period steps. A time study was also conducted for the closing of the table. Again, 3 trials were conducted for each step, and there was a total of 11 steps to close the table. It can be seen that the average standard time was 56.23 seconds. Again, these steps were lumped together to avoid any timing inconsistencies or errors with very small time increments.
We then analyzed the data that we pulled out of our time study and MODAPs analysis and found that there was a 124% error on opening the table and an 82% error when closing the table. That means that there's a pretty large difference between the time it takes to do those in reality versus in MODAPs analyses. Whether or not this derives from an incorrect MODAPs analysis on Sean and I's part, leaving out certain minute details of the process, or it most likely comes from the fact that MODAPs is a perfect movement, and then there's reality, which in reality you have non-value added work as well, which is anything that you have to do your job that doesn't involve the actual movement of doing it. So in that case, you could say the environment has a big play on how long it takes to put your table together. That's where I think that a lot of the differences in time came from. Recommendations for our table. We think that to create more efficiency, improving the table design is one aspect where we go into, where we make larger pinholes to reduce the resistance on pulling them out, taking 2 pins out, thus halving the time it takes to put all 4 in, modification of the pin tethers, which are currently made of steel, which are really stiff and hard to place pins in because of. Additionally, we could add lubricant to the joints to allow the parts to free flow more, or a rubber extension to the side of the table so that the legs can freely rotate. Limitations in our study were that our recommendations are mostly qualitative because we cannot implement these design changes on the table within the scope of this class. We are limited to subjects of study that have prior experience with the table, i.e. me and Sean. We have both put the table together. We cannot impose recommendations to see whether or not they're effective and to what degree, which means that essentially what I said earlier is that we cannot physically do these improvements in the time that we have. And then we also cannot examine the table in Nicaragua, which means that we're kind of doing a laboratory setting, which is drastically different than the rural villages that the table will be actually operating in. That actually concludes our presentation. Are there any questions?